Welcome to aminacademy.com. In chemistry, let us discuss about constructing chemical equations. First, we will discuss about what is chemical equation. A chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulae, where the reactant entities are given on the left hand side and the product entities on the right hand side with a plus sign between the entities in both the reactants and the products, and an arrow that points towards the product and show the direction of the reaction. The coefficients next to the symbols and formulae of entities are the absolute value of the stoichiometric numbers. The first chemical equation was diagrammed by Jean beginning in 1615. The following four steps of writing chemical equation. First, identify the type of reactant and product. Write the chemical formula for each of the reactant and products. Count the number of each type of atom in reactant and product. Balance the equation. Now we'll detail about constructing a chemical equation. You know that the symbols represent elements and formulas represent compounds. In the same way, equations are used to represent chemical reaction. A currently written chemical equation shows the chemical formulas and relative amounts of all reactants and products. Constructing a chemical equation usually begins with writing a word equation. First of all, you have to write a word equation and convert it into symbols, formulas, then balance it. This word equation contains the names of the reactants and the products separated by an arrows. The arrow means forms or produces. Then the chemical formula are substituted for the names. Finally, the equation is balanced so that it obeys the law of conservation of mass. The number of atoms of each element must be same on both sides of the arrows. This is called balancing of the equation. First, we'll write word equation. Look at here. Suppose methane react with oxygen. Methane and oxygen react together, gives arrow mark, carbon dioxide plus water. First we wrote a word equation. Then to convert this word equation into formula equation, use the formulas for the reactant and for the product. Here, first we write methane formula is CH4 plus oxygen is O2, gives carbon dioxide is CO2 plus H2O. Here, then we wrote a chemical equation in formula form. Then you have to balance it. Here, look at here. C left side is C is 1, right side is C is 1. For time being, C is balanced, but H is 4. Here, H is 2. Suppose if you put in front 2, which means you have to multiply these 2 with H and O. Here H is already 2, so 2 into 2 is 4. H is 4 and O is 2. Here H is 4. H is 4. What about O? O is here. O is 2, and here O is 2. O is totally 4. Then we have to put here 2. Now it's a balanced, which means look at here. Left side is carbon atom is 1, here right side carbon atom is 1, and H is 4 left side, and H is for right side, 2 into 2, 4, and oxygen is 4, 2 into 2, 4, and oxygen is here 2 and here 2, totally 4. So it's a balanced. Now, equations are like recipients. Imagine that you need to bake brownies bread for a party. Of course, you would want to follow a recipe closely to ensure that your brownies turn out right. You must know which ingredients to use and how much each ingredients to use. That means what is the reactant we need, and product is the final bread. Special instructions such as whether the ingredients should be chilled or at room temperature when you mix them are also provided in this recipe. Chemical equations have much in common with a recipe. Like a recipe, any instruction shown in an equation can help you or chemist be sure that reaction turns out the way it should. The equation for the reaction between baking soda and vinegar provides a lot of information about the reactants. That means you have to inform about the information about the reactants. Reactants means what you have to add to make a final product. That information must be known before starting the reaction. Now, equation can show physical states and reaction conditions. Equation not only about the reactant and product information as well as how it happened. It follows right side and left side, and arrow mark about liquids, gaseous state, everything it shows. The recipe here, look at one equation, simple equation here. So, for example, N2 nitrogen gas plus hydrogen gas, we can use information about G gaseous state plus H2 also gaseous state, we have write G, and it gives reverse reaction also. Here forward reaction is this, which means we have to use 350 degrees Celsius and pressure is 25,000 kilopascal. That means pressure and temperature turns this N2 plus H2 react together and forms ammonia, NH3. This also gaseous state. That means this reaction gives lot of information. What are the reactant states? This N2 is a gaseous state, H2 also gaseous state, and we are giving 350 degrees Celsius and 25,000 kilopascal pressure. It gives it gives NH3 ammonia gas, and here if you return back, you have to add catalyst. That means from NH3 crackdown we produce nitrogen and hydrogen also, this reverse reaction. So this double arrow indicates that the reactions occur in both forwarded and reverse direction, and then the final result is a mixture of all. That means what is this is the product, NH3 is a product, these are the reactants. This equation itself gives the more information about states and conditions. When to use the symbols? Although chemical equations can be packed with information, most of the one you will work with will show only the form of reactants and products. However, sometimes you need to know the states of substances, that means liquid, gas or solid like. However, sometimes you need to know the states of the substances, recognizing and knowing the symbols used will help you understand this equation better. And learning of these symbols now will make learning new information that depends on the symbols easier. Here that chemical equation, here balancing it check first. Here N2 is 2, H2 is 2. Here you have to balance this. How to balance this? Look here, N is 2. I put 2 here. That means 2 nitrogen, 2 into 3 is, because 2 is multiplied for both, 6 hydrogen. Nitrogen is 2, 6, here left side H2 is 2, so I have to make it 3. So we balanced also. So far we discussed what is chemical equation and what is reactant product, and as well what is the 4 steps to write the chemical equations. That is, identify the type of reactant and products. That means what are the products and reactant you must understand, as well as write the chemical formula for each of the reactants and products in left and right side. Count the number of each type of atoms in reactants and products, that is balancing the equation. Here, for example, we did methane plus oxygen gives carbon dioxide plus water. This is a word equation. Then we convert this word equation into formula form, and as well we balance it. One more equation. This gives more information than before. That is, here this, what is the state of reactants? Here gaseous state plus gaseous state, and what we have to give further to improve the reaction, that is 350 degrees Celsius, and as well as 25,000 kilopascal pressure you have to give to form a ammonium gas. And as well as the reverse reaction is this side, that means NH3 gives, by using catalyst, that the reaction gives as a product N2 and H2. If you have done, please subscribe our YouTube channel.